Sorry if that jumped a little bit there, just interruption. So we were just talking about how we select and what we're looking at here is the M42 nebula. We can see over the course of a night what it's going to be doing. We can look over the course of a year as well at the path that this nebula would take, and we can find out that the best time to image this particular nebula from Wellington is when it's at opposition. That's December 16th, and that's when it'll be as high it'll possibly be for as long as it'll possibly be in the night. That's at midnight, so in the middle of the night. When will it be at its highest? That's a good kind of starter for 10. If we were to image it today, you can see it only reaches 53 degrees, so it's actually quite low, and even the yearly peak altitude is only 53 degrees, so it's well in that range of able to be imaged by our instrument, but it's not ideal. We'll see some other targets to get a little bit higher and we shoot through a little bit less atmosphere. So how do you check whether it would fit in our field of view? Well, you look at the telescope simulator down here, and what I've done is I've set up again our focal length of our particular instrument, 1520. I've set up the camera, the QHY 600 camera that we use on there, and so that's putting on what we would actually see in the night sky, and we can actually move the object around, so we can have a look at how we might like to frame the particular object. We can adjust the brightness of the image and the contrast and the saturation and other things to give us a better kind of feel for it. We can increase the saturation. We can choose different images, whole sky survey images, so we can look at it in H-alpha or infrared or X-rays. Lots of other ways of kind of looking at different objects, which is useful. The thing that we use now is we probably want to work out how we're going to frame this image, so we can actually rotate the frame around until we find an orientation we like. Just on the Cretney instrument, I tend to stick with 0, 90, 180, 270, because that will give us the star spikes, diffraction spikes up and down and left and right in the frame. You can use kind of 45 degrees if you don't mind diffraction spikes of the brighter stars being rotated 45 degrees in the frame. Tend to stay away unless it really needs from arbitrary kind of in-between angles, because that causes us visually it looks a little bit odd if the spikes are just a fraction rotated, and they rotate with the camera and the sensor because the camera is rotating relative to the spider, which is actually the bit that holds the secondary mirror and causes those diffraction spikes. So we pick an orientation, and like I could probably put the arbitrary one in that gets a bit more of the framing in. In this one, if we wanted to frame both it and its companion nebula, and we can kind of just get it to about the right point. And then the key thing is to for us to come into here and then to record the position of the center of the frame and the rotation angle, and we can tell the Cretney instrument to go to that location and use that rotation angle, and it will take an image that then is very similar to this orientation. The other thing we can do, if we, as we see, can't get this whole subject in this one size, so we could actually decide to take a, for argument's sake, a 2x2 mosaic, and let's maybe overlap the frames 20%, and that gives us the ability to take 4 separate images that each overlap by 20%, and it gives us here then the coordinates of the center of each of those frames and the rotation of each of those frames. We can put that data, copy the data out here, and then we can put it into the Cretney, and we can take those 4 images, and then we'll be able to stack them and create a single image that covers that larger portion of the sky. So that's kind of basic framing of an individual target. You can just check if it's about the right size. We'll just maybe have a look at one other example. So here we looked at all types of objects ranked by popularity. If we come into object type here, we can choose other than emission nebula. Maybe we're interested in dark nebula, and it will give us a whole list of dark nebula. Sorry, I have to turn emission nebula off. It will give us give us just dark nebula, so dusty regions that we might be interested in taking images. Again, here we can see by popularity and when they rise. So at this time of the year, we're not actually able to take images of these objects at all because they don't rise high enough. But it doesn't mean we shouldn't add them to our list and work out when we can take their images. So if we look at a very popular target and one we've imaged a little bit through with this instrument. In fact, you might actually see some of the Cretney images through here because some of them have been uploaded into the background. So some fantastic images up here, as you can see. The best time of year would be when it's in opposition at midnight, so in late May. So we might look to take this image of this particular target sometime between May and June, which would give us at the highest point of the night somewhere between 50 and 70 kind of degrees of elevation, which is much better, less atmosphere to look through, better quality, better stars, all those sorts of things. And then you would see that transit time would move into the 12 o'clock slot in the middle here. Obviously the duration of the night is also longer for us at that time of the year as well, so we get a longer duration for us to image that particular target over the night. So that's kind of another way I would go about looking at them. One useful thing if you're looking for something to image sooner rather than later is, instead of popularity, is to order them by next opposition or rise or set time. But here it's all of the dark objects that are available. We can also say we want them to be above 40 degrees for argument's sake, and we want to image them for several hours in a night, say 3 hours of imaging as a minimum. And so we're filtering those results to only target dark nebula that are higher than 40 degrees for more than 3 hours from our particular location. And so here you can see a really good candidate here, Sandquist 5 is tonight will be up to 81 degrees at midnight, and at dusk it's at 56, and at dawn it's 54 degrees. So all night we can get 6 or 7 hours on this target easily. So that might be a good particular candidate. We might be interested in that. Can't really tell much from this image because not many people have imaged this, and no one's uploaded this particular image. If we go back to our telescope simulator, we'll put it back to 1 by 1 rather than a mosaic to start off with. So again, we can't really see anything here. So if we really bump up the brightness and the contrast, we can see there's some nebulosity, dusty nebulosity through the center of the frame here. It's hard to work out whether it's just this kind of much smaller target that we're talking about, but that might be a candidate, might make a really interesting image. It's pretty faint because it's not being pulled out from the background, so it's going to need a lot of time to acquire that. The other thing I like to do is also just kind of pan around a little bit and see what else we can find in the vicinity of, to see whether there's like better candidates or better framing or more interesting information, more interesting targets nearby. And so, by this way you can kind of look for things that aren't catalogued and a little bit different as well. Open cluster here that might make for an interesting image, and some nebulosity by the looks of it through here. So this might be something quite famous. Is this the cone? Maybe, I don't know. So again, I would set this back to a normal orientation. Might choose 90 degrees in this case. I'll get those star spikes that we're going to get from those bright stars. Think about the framing composition. So we might want the cluster up in the corner of the frame and some nebulosity going off the side, or we can have a think and a play about how we might kind of frame that particular object. Might have some O3 coming through this way and some HA up this way, so we might want to get some narrowband on this particular target too. Not sure what it's called here, it doesn't tell us right away because we've moved well off of our Sandquist target, but we can get the coordinates and the rotation out of here again, and we could just take some imaging and just see what we get. So that's kind of the point of it. Yeah, so lots of information there. Best time of the year, transit time, trying to get that elevation, lots of things to try and pick. If you recommend a target and it's not the optimum time of the year, we might still be able to image it, or we might need to wait till another part of the year to actually go after the target that you've identified and recommended. So other places to look, there's heaps of information on here on Telescopius, lots of different types of targets that you can have a look at, really obscure things. You can filter by size. You can put in that 1 degree size, that we don't want anything smaller than 1 degree if you like. That would mean that we get a good kind of filling of our frame of those particular targets. We've got the ability to make sure it's high enough to image well for long enough. We can change the object type in here as well by selecting other types of target. Planetary nebula typically a little bit smaller, so these ones might be very small targets, 15 seconds here, so that's going to be way too small for our scale. 1 degree, so we already know that's going to fill our frame quite nicely. 6 minutes is like a tenth of our frame, so it's quite small. So you can get a feel for the sizes quite quickly here, or we can actually just filter out by apparent size, have a minimum size of, say, half of our frame, 30 arc minutes. So now we're only seeing images, targets in here that are greater than 30 arc seconds, and then we've filtered them by rise time. So if we're looking for something close to the middle, what I normally do is turn this up to 100 targets per, so we can see lots, and then scroll down the list and wait until it loads up. And then these targets here, supernova remnant, we've got some other dark nebula, but this one very high for long duration through the night. Doesn't tell us the size, unfortunately. This is probably quite small, although it's supposed to be more than 30. But yeah, so that's how I go about typically looking for things that might be interesting. You can, if you have an account, you can log in, it's free. You can then add it to your observing list, have a list of different things. You can open it in Stellarium, you can send yourself a reminder for when it's the best time of year to image it, when it's reaching that highest altitude in the sky. And yeah, have a look, have a play, come back to us with some suggestions. Other places you can look, we talked about Telescopius, Astrobin. There's heaps of great images on Astrobin. You can have a look at the images that we've taken with our telescope already. So they're most of these ones, the most recent ones, are images from the current Cretney setup. A number of my older images are when we were testing with the C14, so that's a different focal length instrument. But you can tell on any of these particular images what instrument they were taken with. When you click in them, it'll tell you the equipment that was used to capture that particular image, and you're looking for the Refast 400 and the QHY 600 combination. That's the combination we've got in the observatory at the moment. So that's a good way. You can also have a look on exploring things like image of the day and top picks. So these are voted for by users on Astrobin as some of the best images, the image of the day. So this might give you some inspiration of the sorts of things you might like us to point the telescope at. And then we've also got the top picks and the top pick nominations, and these change every day, every few days. There'll be more images placed into here. So you can just have a quick scroll through and see which of the images appeal visually and would be of interest for you to image, and then look them up in Telescopius, see if they're the right field of view, see what time of year is best to image them, and then make a recommendation to us, and we'll endeavour to try and capture that data. From there you can process the data, we can process the data, we can talk about that, but really I'm not going to go into data processing. I'll do another recording around data processing. The point of this was really to encourage you to go out there, research different topics, look at some of the amazing things that we can point our telescope at, see whether they might be right for our equipment, and then reach out and get involved, and we'll be imaging some things that you've recommended very, very soon. So just in closing, places to look: Telescopius, the IMM catalogue, Astrobin, Instagram, Facebook, plenty of other Google searches as well if there are things of interest, plenty of places to look for inspiration. So that's about all I wanted to cover. Thanks for listening. I know it's been a little bit longer than I had perhaps anticipated and hoped. We've covered off the equipment and the field of view that we've got. I'll be able to provide some links in the description for that. We've talked about its best imaging near the zenith, and that changes. The altitude changes throughout the night and throughout the year, so trying to find targets that are right for us right now, or else be prepared to wait until we get to your target till it is optimal. We talked about different types of target, from nebula to open clusters to galaxies. Typically, galaxies are a little bit smaller and perhaps a little bit harder for our instrument to go after. So the best ones really are different types of nebulosity. We can definitely image the moon, although that's different. That's done with videos rather than stills, so it's a little bit different. But we can definitely image the moon with our setup. We can look for comets, although maybe not get the whole comet in the tail, because they're typically very big, some of the comets we've seen recently, but we could get the core of the comet. Heaps of different types of nebula, so they're probably the things we should start looking for, whether we want to do some of the bright pinks and blues of HA and O3 and S2 types of emission nebula, or whether we're looking for reflection nebula, or dusty dark areas of the sky. They're probably the things to focus on to start off with. We will help sort them by the best time of year, best transit time, work out when we should acquire the data, and really just encourage you to get involved, have a look, see which images you like, see what you think looks cool, and we'll do our best to try and capture some of that data. If you have any questions, as ever, get involved, reach out, happy to try and answer those questions. And we'll also be looking to train the first cohort of users to actually get hands-on with the telescope very soon. But in the meantime, helping us pick some targets is a great way for you all to get involved. Hope to see you very soon. Clear skies, and yeah, thanks for your time. Cheers.